Alright, welcome back generals to another Let's Fix Generals 0 Hour to make the best game ever. Okay, we are still developing an unassemblize tool, and last video I did something here in Runner. Right, we wanted to change this array to vector, which we did here. Before I want to continue with this, so right now this won't compile, this whole bunch of compile errors here. I think we need to think about how we actually want to use a runner from another thread. Let's create a new class and file, runner q dot h. Okay, and runner q dot cpp. Then we go to our CMake list, and we put here runner q. Then we compile that, and we'll get some fat errors. Okay, then we go to our runner queue, and we will class to instigate all high-level functionality for unassemblize from another thread. Okay, runner q dot h. So you need the namespace unassemblize. Okay. It also probably will need to know the class runner, but we can probably forward declared here. And we have a class runner q. And in here, we will definitely need to include reader writer q. And reader writer q, is this in some namespace? It is Moody Camel. Moody Camel, that's a weird, it's a weird namespace. Okay, reader writer q. So using reader writer q equals Moody Camel. There we go. Takes arguments. Max block size. Okay, then we do T. Okay, so we will need some sort of read operator Q. Max block size. Sorry, what does this mean? Max block size. Max block size. Let's define exceptions enabled 0. Okay, so my impression is the block size just says how many elements we have available to pick up, right? Let's search for all occurrences. Max block size. Create a new block. Make block. Make block. Okay, so this will allocate. Yeah, okay, so it's probably the size we have. My suspicion is that our queue doesn't need to be super large. Probably, I don't know, 32 is probably plenty. Okay, so we will need a queue that like a command queue, and then we need a result queue or something like that. Command queue, results, result queue. Yeah. Okay, and then we need some kind of types for these things. So I would say we have to use inheritance here. We use struct command say runner command. Yeah, that will have virtual destructor. Default. And yeah, and we need to have like structs. No, in class command type. Runner command type. Runner command. Okay, and then here we have a bunch of types in here. And then if you get type, just call it type const pure virtual. And then we have some structs. Then runner commands. Runner command. So for example, loads executable, loads exe, right? Let's just put two examples, load exe and load pdp for now. pdp. And then, so command time will be load exe and load pdb. Then here we do const overrides, and that would be return command exe, and we also have destructor overrides default. And here that inherits from public that, no, that. Same here. PDB, loads PDB. Okay, and then we can specify things here like std string. What does this take here? Let me see. Runner here. So file and config file, right? Yeah, so actually we should probably include runner here. And we should probably just say here this is runner here exe safe load options, right? And here we do PDB safe load options, right? So you tell it like, okay, I want to do this here. Please take it, right? And what is it complaining about? Ah, this one also needs to inherit. Yeah. Okay, then we can add here more of these guys, whatever we need. And then what we probably need is include memory. And we need to create a std using runner command ptr pointer equals std shared pointer. Shared point air. Runner command. And so basically here our command queue will have pointers, the runner command pointers. Yeah, and then we would have a struct runner runner results. Is the result a good name? Command. Runner results. Runner results. Runner command. Okay, how about we rename it to runner q command. It's a little, names get a little bit long, but maybe it's okay to be explicit. Run our Q command. Then we do run our Q results. Yeah, Q result. Q command. Q. Yeah, Q result is okay. Okay, and there we pretty much do a similar thing. Let me think. We probably also want some kind of ID here, even if it's just for debugging purposes or identification purposes. So let's put the destructor at the top. Static. Not atomic, because intended to be created on single threads. So we have static here, static ID. Let's do here simply ID equals SID plus plus. Okay, then we initialize this guy here. Static runner Q command un32t SID equals 0. There we go. Okay, so we will have a counter implicitly here with this base class. Q result. So then we can associate. Let's name this command ID. Command ID. And then here we give back in the Q result the command ID. Command ID. Results, command ID. And we can probably also give back the Q command that actually we can just give the Q command pointer. Yeah, which then contains everything. That's a good idea. Q command ptr. We do commands. So we give back that. But of course, we will also give back result. Yeah. Command ID. You can probably make this const. Like that. And here, this we can also make consts. Then we pass it here. Const commands. Commands. Maybe not. No, that works. Yeah. Let's do we want it explicit? Explicit or not? Probably. Yeah, make it explicit. So, and then we also need to make this a shared pointer, which we give back. Shared pointer that. And then we will also create structs like this with runner q results load exe and this one will inherit this one. And now the question is, do we need type? We do need a virtual structure. Do we need a type? Yes. Well, no, because the type we know from this guy. So we can check in the command what type is it. Yeah. So we don't need that. What we can do is we can here create a helper function. Type. Here. Non-virtual const. And we just return commands dot type. What? Oh, this one. Okay, and this, and then here, what do we return here? We would load PDP. We would probably return the executable, right? Executable, how does this currently look? Let's see, unique pointer. Okay, so I think we return a std unique pointer of executable. All right. And then we can do whatever we like with it. Yeah. And then here we would return PDB reader. Yeah. Yeah. I think this could work, and then here on our queue, we then give back this guy here, result point. No. Shared pointer. Yeah. Yeah. This would be what I would expect the data to be like. We have here our pointers. We have these virtual classes. The data is with virtual table. We can cast them according to the type here that we have, and then inspect the arguments here. They have a unique ID for whatever purpose. And yeah, we send it away, the command, then we wait for the result queue until something arrives. And when we get a result, then we can use it. And since it's in a unique pointer, we know that only we own this executable thing, right? These things are shared. Do they need to be shared? Or can they also be unique pointers? I don't know. DQ. Now this. I suspect we can't put unique pointers in here because it doesn't have move. Or does it? Does it have anything with move? Yeah, here it does. Okay. NQ. Okay, we can actually move. Okay, so we could move unique pointers in there. Which maybe is better because then if we move our things into our queues, then we have a guarantee that no one else can change the state when it's in the queue. So we create it on one thread, we create the command, and then we move it into the queue, which means by contract we give it away, our unique pointer. Yeah. And so no one can change it after the fact. Like, oh, I want to change the command to something else while it's being processed. That would be illegal because then there could be a race condition and crash. Okay, so how about we try to make this unique pointer as well? Maybe unique BTR. Maybe it will be just fine. We'll see. Unique pointer. Okay. Then we will have a public and we will have a private. Yeah. And so the runner queue, constructor and destructor. Runner queue. Actually, we need to pass it something. We need to pass it. Yeah, the runner queue. The runner. Runner queue. I think we should make our runner static. All functions static. But then we can't have nice things in the cache. Okay, right now all these functions are not static because of these guys here. But perhaps they should live outside and we pass these things. Right. Okay, so I'm not sure. Runner, should it have state? I mean, right now, I mean, if we give back executable and PDB in like such a result here, then the runner doesn't own these anymore, but the invoker owns these. The invoker owns the data. In the UI, the ImGUI app owns this data because it needs to draw it all the time, right? Needs to, well, executable. That's a question. Should the runner own any state? Maybe he shouldn't. So he shouldn't own this, because then it's easier to reason about the data. Like if all the commands we pass in, we also give all the data to work with, then it's easy to reason about this our data. We know in what state it is. Yeah, I think that's better. Yeah. Okay. Good. Then let's add a function here. Yeah, actually, how do we do this? We have a runner queue. Result queue. So we need a function to add a command. Yeah. And we also need a callback when the result is ready, right? Or we just have a function to try get. Okay, let's go in this queue. So we have okay. Only fails if memory allocation fails. Okay, so we need this enqueue. Construct in place. No, I think the just enqueue is fine. Okay, let's get a notepad. So we need the enqueue. I appreciate that there's nice documentation. If the queue is empty, returns false. Attempts to dequeue an element. If the queue is empty, returns false. Moves front. Is there any other DQ? Or is it just try DQ? Peak front element. Wait, DQ. No, wait, we don't want. We don't want to wait. No, we just want to check, is there something in it? Yes, good, I do, I work with it. No, I keep on going. Yeah. Timed. No, we just need the DQ. Try DQ, I think. Let's see if there's any other. Wait, DQ timed? No. But hold on. Oh. We can't DQ with move. Right. That doesn't work. We can always add to the queue is move, but we can't pop from it. Why not? DQ. DQ results. Try DQ. Inner. Well, it does move here actually. So we can do it. Yeah. We can use unique pointer. Okay, that's cool. Good. So wait, let me go back once more. Try DQ. Yeah. Okay. Odd that they used U here instead of T. Okay, so you can pass a type that is different to the actual T, as long as it can be assigned the T. Okay, maybe it makes sense, yeah. Okay, but we don't worry about this. Okay. Yeah, I think it will work. So basically we just expose these two functions. We put here our runner q command pointer, ref, call this command, and DQ, we DQ this guy. Results. Yeah. And that would be that, yeah. And then do we really need to put it here? I think we can. Yeah, let's do it here. So that would be runner queue. Okay, so basically we just need to return command queue dot enqueue commands sd move commands, and here we need to return result queue dot try dq results. Okay. Okay, so this would be the public functions. And then we need try dq. So runner queue. Runner queue. Runner queue. Mm-hmm. Runner queue. Okay. think we also need to create a command quit to allow stopping the queue. We just have it empty. So quit. Quit. Oh, I need to think a bit. So the runner queue. So UI creates this runner queue, and then it can enqueue the commands that we give it from the UI, and then we can try dequeue every frame and see if there's something in it. Good. But then we need maybe we should create a new class, runner queue thread. Okay. And here we will have a public function to class, oops, to friend class that, and I mean, if this is default, might as well just remove that. Does it need anything in the constructor? Explicit. Construct a queue that can hold at least size elements without further allocations. If more than max block size elements are requested, then several blocks of max block size each are reserved. If more than max block size elements are requested. Okay. Size 50. Okay. In that case, maybe we let's put it back. Let's put here command Q. At least without further allocations. Okay, let's give it 31. I don't know if that's smart. Maybe the larger block size makes more sense. I don't know. It's not really. Let's look at this once more. Constructs a queue that can hold at least size elements without further allocations. If more than max block size elements are requested, then several blocks of max block size each are reserved. Several blocks. Why several blocks? I don't understand. Yeah. Okay, well, whatever. Let's leave it like this for now. Good. Then next step. Our runner queue thread. I would say here we create an explicit and we give it the runner queue. Or should it just own it? No, we give it to that. We give it const. No, it's not const. Can access it. Queue. And that will then have a reference to runner queue and can mingle with that. Queue. Queue. Okay. Okay. So this thing C++ thread start threading. Let's find here thread task threads. Yeah. Okay, let's include yeah, let's make this, put that here. Okay, and Q. Okay. And then create here I think we can spawn the thread right in the constructor. Yeah. No, let's Let's just pass it a pointer. Include threads. Maybe it shouldn't be. We want. Okay, so UI owns the queue, so it can interact with it. With the queue, maybe it should just be part of the queue. Maybe it's better to just make it all part of the queue, so it's closely coupled together. Yeah. Okay, so let's say we put here a include. Oh, I can't type. Include threads. I really can't type. Oh, good. So. Okay, so let's put std thread here. Can we actually put it here? Does it? Okay. So I would say we create a void start. Yeah, start, stop, and join. Okay, so start, stop, join, enqueue, try, dequeue. Okay. And so here on join, we would just thread join. Yeah. On start, we would dot. How do we start this thing? Okay, so thread equals threads. Cd threads. It's private void threads function. Static. Does it have to be static? I think so. Then we have to give it this thing, I think. Q. Well, let's say self. Let's put thread function member. Thread function. Say updates. Updates. Or let's say thread run. Thread run. Okay. So here we just call p self thread run. And thread run, we then actually do the work. So here thread function. And we pass this, right? Do we need to detach? Join, detach. Thread detach. What did that do? Separate the thread of execution from the thread object. Ah. Huh. what? So it's like to release this thread here from this object or what? I don't understand. Possible output. Hey. Either join or detach. Yeah, okay, that makes sense. Okay. But we want it to be joinable so that we can invoke a stop and then we can stop. Okay, so the stop, how do we invoke this? We just need to, we have a command queue. And we call enqueue std make unique queue command quit, right? Yeah, make unique and that. This is how we would stop it. Yeah, stop. Maybe put an assert here. And thread dot what is joinable? Joinable means the thread runs, no? Let me see. Threads, joinable, checks whether the active threads. Yeah. So, okay. So here we just say thread dot joinable. So we don't expect it to run, right? Yeah. Okay. Oops. Okay, so we started here with the thread function, give it this pointer. We stop it by enqueuing a command quit, and we allow it to join. After we call stop, we can then join, and then we wait for this, and then we can quit. Okay. And then here, thread function. But it would mean that we first have to wait for all the commands to actually quit. Yeah. Well, we could have But the problem with this approach is, like, if there's a big backlog of work left to process in the command queue, and we send this command quit, then it has to wait until all the other things are done. But maybe we want to abort. For that, we would need abort queue. Sure. Yeah, I guess you can worry about this another time. Like, how do we want to cancel operations? That's a whole nother story. Cancel. Like, if we just have a simple command queue and we push things, then we can't really cancel it. Canceling the command queue. Let me think. Well, that will only work if our runner queue, if this guy then spawns worker threads to actually process the commands, and it can still listen to more commands. Okay, but I think for now, let's keep it simple. Let's keep it simple. Yeah, basically we would need to have, so cancel. Okay, let's just implement it with one thread. But to me, it looks like we will end up with more than one worker thread. Yeah, because we need this queue thread that like just deals with a queue, and then that guy spawns workers to work on things. So we probably do need a job system, some sort. Yeah. Okay, but let's do it simple first. Let's not complicate it on the first pass. Okay, so thread run here, we would just say while true. While true. Q command pointer ptr commands m result q dot wait dot command q dot There are two types, aren't there? Blocking. How do we do waits? Is this private? It's public. Blocking. Ah, so we have to use this. Provides blocking operations. Okay. Okay, then let's change this to the blocking queue, because but only for the command queue. Yeah, let's create a copy of this guy. Blocking. Okay, so this guy needs to be blocking. Command queue dot wait dq. Yeah, and that is command. Yeah, wait dq. Okay, and then if it has a dq, then we will have a switch for command type, and then in here we will have case runner queue command type, and there will be a quit and case runner command loads executable break case runner command type load pdb, and then here we basically do things dot 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 dot. Okay. For the quit, now since this is a switch case, we can't really you know what, I haven't used go-to in, I don't know, years or never, but I think this is a good time to use a go-to. Let's call this quit and just go to quit. That's, I guess, simple enough. Yeah. Like that. Yeah, so basically this thread waits for the command, for a command to arrive infinitely. And once it gets the first, it will process it, and then the next, and so on. And if it gets a quit command, it will exit this loop and will exit the thread. And then the caller can then call join and wait for the quit, and then he knows this thing is done. And here, if we have other jobs that this queue manages, then we can wait for those jobs to finish first. And then maybe we can have like something that we say, hey, please abort whatever you're doing right now. And then it would wait for the abort, and then it would quit. Yeah. Let's put a comment here. Wait for jobs if we have them. Wait for jobs here when applicable. Okay. Yeah. Yeah, I think this should work. Yeah. Yeah. Okay, and then here we would then call into runner to do the work. For that, okay. So what we definitely need here is, how about we make functions? Let's make a static. Static process command. And then we put the command to here, load exe. Command. Then we need to return something. The result pointer. No, we don't. We don't. Well, we can. Load PDB. Load PDB command. Okay, so let's say we have this here. Okay. And put that here. And the formatter is out of control, pretty much. My gosh, I hate this Clang shit. Clang format shit. Okay, so, do we... Yeah, no, we don't do it like this. Hold on. Side pointer. Actually, we can. So we put a result here, results. And then we do result equals process command. And there we pass static cast. Static cast. So we have a command here. And we pass it this. Dereference. Okay, like that. And here we need to make it run a q const. right? Const yeah. Yeah, so here we do pdb. Here we can put assert command is not null pointer, and results. And then here at the end of it, we put m result q dot employees. Wait, nq. That's the correct word. nq. nq std move that. Right. And then here we basically so we have a here results, and we need a auto results equals std make unique that, right? And then return results. And so here this result will have dot executable, right? Pointer executable, right? And this one we fill with something. Okay, and here we have loads pdb. And here we do something with the pdb reader. Right? Yeah. I think this flow will work, yeah. Now it will have the problem that I've described earlier, that this thread will be super busy with the queue. So we probably want jobs here. We want this queue to spawn jobs. But then yeah, those jobs can then also enqueue here. Yeah. Yeah, I think it will be possible. Okay, but let's do it like this for now. It should be okay. Okay, then let's remove this. Okay, here we have some problem. What is the problem? Okay. Yeah, and then basically we have these commands functions for all sorts of things, and it's a static function, so we can actually, yeah, open this in the thread. Yeah. But we probably want the job system for this kind of thing. Yeah. Okay. It's let's put a to do here. To do spawn jobs for commands to unclock the queue. Yeah. Okay, but I think for now it's simply enough. Okay, then we need to implement this, and we also need to make changes to the runner to actually, we need to make everything static here. Yeah, we need to make some changes. So that we'd say, yeah, okay, I think for starters, we just support the functionality that we currently have here, which are these few things essentially. It's not great. I think it will be okay. Yeah, yeah. Why can't this be empty? We should probably make a constructor for this thing. This can't be empty. Same for these guys. Yeah. And then we need to pass here executable and PDB reader and all these things. References. Yeah. Okay, I think this will work, yeah. Okay, what's the time? Close to 2 hours. I think it's a good time to take a break. And then, so next video, we will make the changes necessary here to the runner to have it all function static. We remove these guys here. So this means it has no state. This thing has no state. You pass it you pass it things to work with, data, and then it just works on it and gives you a result. That's it. Yeah. So the results, here's some outputs. Yeah, so the result here is basically, it just prints something. Okay, but that's fine for now. And here it does a comparison. Yeah, okay. I mean, this needs to be changed as well. Like it needs to return like the actual result so that we can then use it. But let's keep it simple. Yeah, let's. Yeah, let's do one step at a time. We have to do multiple things here, but let's try to keep it simple. Okay, I have a general idea. Yeah, then we do that. Okay, it's quite a bit of work to get multi-threading running for this. Just the first iterations. Yeah, there's plenty of work. We haven't even gotten starting with the UI. But first we need to like give data to the UI. So yeah, that needs to be done. Even if it's just simple for now. Yeah. Okay, good. Good, let's save all the files and let's take a break. All right, then I wish you a great day or night. Until next time, goodbye.